The topic of this video is cost theory. In the video on production theory, we have said that it is very difficult to observe the production technology of a firm. However, if we know something about the output of a firm and also the cost to produce that output, we can actually say something about the production technology. This is called duality in economics. Now, in the first part, we are going to look at the relationship between production and the cost function of a firm. Now, suppose that we have a Cobb-Douglas production function where we produce output Q, and we produce this output Q with two inputs, capital and labor. Now here we have K times L and the square root. This can also be written as K to the power of 0.5 and L to the power of 0.5. Now we have two inputs, K and L, and the prices associated with those inputs is 1 for the per unit of capital, so R is equal to 1, and the wage is equal to 2 per unit of labor. Now, assume that we are in the short run and that the capital is actually fixed in the short run at 9 units. So when we take the square root of 9, which is equal to 3, we have 10 times 3. We have the 30 times the square root of L, which is the production function in the short run. Now, here we have a table that depicts the number of workers, 0, 1, 4, 9, and so on. Note that I have chosen those values to make the calculations easier because you can easily take the square root of those values. Now, let's start with the situation where we have 0 workers. If we have 0 workers, then we have the square root of 0 is 0 times 30 is 0, and hence with no workers we do not have any output. So the output is 0. Now note though that we have fixed capital in the short run at 9 units. So what this means is that despite the fact that we are not producing anything, we are still incurring the cost associated with capital at a rate of $1 per unit. And hence the fixed cost is 9. Now, what do we mean by fixed cost? Note that the fixed cost is something the firm has to pay even if the output is 0. Now, consider, for example, all the airlines which were grounded and affected by the COVID-19 pandemic in 2020, despite the fact that they were not producing any output in the sense of providing flights to passengers. They still had to incur fixed costs associated with, say, the maintenance or even the loan payments on the airplanes. Okay? So fixed cost is something that is independent of output, and it is also, you have to pay it even if the output is 0. Now, since we have the variable cost varies with output, so in this case we do not have any output because we are not employing any workers, and hence the variable cost in this case is equal to 0. So the total cost, if we have 0 workers do not produce any output, is equal to 9. Note that the total cost is simply the fixed cost plus the variable cost equals the total cost. Now, what about if we have a worker, if we employ one worker, then that worker is going to produce output in combination with the capital. So we have the square root of 1 is equal to 1 times 30. We have an output of 30. Now, the fixed cost here has not changed because we are still simply employing 9 units of capital, so the fixed cost is 9. But now the variable cost is not 0 anymore because we are now employing this worker that costs us $2, and hence the variable cost is 2, and hence the total cost is 9 plus 2 is equal to 11. So now note that for the remaining units, or for the remaining workers or levels of workers, we can easily calculate the output. So if we have 4 workers, take the square root of 4, we have 2. So the output is 60. The square root of 9 is equal to 3, and hence the output is 90, and so on. Okay. So if you're thinking about the square root of 36 is 6. 6 times 3 is equal to 180. Now note that since we are in the short run, the units of capital we employ does not change, and hence the fixed cost does not change. So this is always going to be 9. Okay. However, because we are now employing more workers, this has an effect on the variable cost. If we are employing 4 workers and each of them costs $2, and hence the variable cost here is 8. If we are employing 9 workers, the variable cost is 18. If we are employing 16 workers, it costs us 32, 50, and 72. Okay. And now we can see that because we have the fixed cost and we also have the variable cost, we can now calculate the total cost, which is 9 plus 8 is 17, 27, 41, 59, and 81. Now, let us have a look at the 2 columns that are important here. Note that we started off with a production function, and we know the cost associated with the units of input that we are using, and hence we can have the first part, we can link the workers to the output. So here, this is the link provided by the production technology, or by the production function. But now we also have a link between the total cost, which is the last column here, and between the output. Now, those 2 columns, or the relationship between those 2 columns, will make up the cost function. And this will be the subject for the remainder of the video, this relationship between output and total cost. So here is a computer-generated graph of the information we have just seen. On the left-hand side, you have the production function, or the short-run production function, where we have Q as the output is equal to 30 times the square root of L. So if you look at the table we have just constructed, if, for example, you are having 9 workers, or you are employing 9 workers, then your output is 90 units. Or if you are employing 25 workers, then your output is 150 units. So on the left-hand side, we have the production function that is representing the production technology. Okay. Now, in the previous exercise, in the previous problem, we have seen that we can relate output to the total cost function. And this is what we are doing on the right-hand side here. We have the output or the Q on the vertical axis, and we have the dollar amount, or we have a dollar amount on the, we have the output on the horizontal axis, and we have the dollar amount on the vertical axis. So for example, even if we have an output of 0, we still have to cover the fixed costs that were 9 in our case. Okay, so here we have 9. But then if we are increasing our output, we can see that the total cost is increasing as well. Okay? And so, for example, if we have an output of 150 units, okay, so here we have the output of 150 units, then the cost associated, the total cost associated with that output was $59. Okay? Now, you can see that the shape of the production function and the shape of the cost function are related to each other. So you have the production function that exhibits decreasing marginal productivity. And so what this means is that for each unit of input, you're producing, the rate of production is going to decrease. The consequence of that is that the cost function is shaped like this, in the sense that if you are increasing your output, you have a disproportionate increase in the cost of production. The purpose of producer theory is to derive the supply function of the firm. Now, in the next step, we are going to get closer to actually deriving the supply function of a firm, but we are going to need to go over some very important concepts beforehand. What we have seen so far is that we have fixed costs that are independent of output. Even if your output is 0, you have to pay the fixed cost. And then we also have variable costs that vary with output. So if you are increasing your output, your variable costs are going to increase. Now, the total cost is the sum of the fixed cost and the variable cost. So this is what you have in the graph below here, where you have the output on the horizontal axis and you have a dollar amount on the vertical axis. Okay? And here we have the dollar amount is equivalent to the cost. Now, when your output is 0, so you have a 0 here, then even if your output is 0, you are still incurring the fixed cost because that is independent of output. But then when you are increasing your production or when you're increasing your output, then you're also going to have the total cost. Now note that the cost function or the total cost function, which I have depicted here, is corresponding to the production function, which we have seen in the chapter Producer Theory. Note that the production function corresponding to this cost function exhibits increasing returns to scale in the lower part and decreasing returns to scale in the upper part. Okay? Now note that I have not only drawn the fixed cost, but I have also drawn the total cost, the total variable cost. Okay? So we have the fixed cost, we have the total variable cost, and then the sum of the two is represented by the total cost function. Okay? Now, note that the average total cost tells you the average cost per unit of output. So, for example, if your total cost is, say, $500 and you're producing 10 chairs, then the average total cost per chair is $50. Okay? Now, if you have seen the video about producer theory, in the video on producer theory, we have looked at the average product and the marginal product. Now, in this video here, we are going to look at very similar concepts. Okay? So what we are going to do is we are going to derive in the bottom graph here, we are going to derive what is called the average total cost and the marginal cost. Now, we will see that the marginal cost is an extremely important concept. Basically, what the marginal cost tells you is how much is your total cost going to increase if you're producing one additional unit of output. What this corresponds to is the slope of the total cost function, okay? Or think about this as the steepness, okay? Now, let us first derive the marginal cost. But before I do so, if you're comparing the total cost function and the total variable cost function, then the only difference between the two cost functions is the amount of the fixed cost. Okay? What this means is that the total cost function as well as the total variable cost function, that those both curves are parallel. Okay? So if you're thinking about the marginal cost, it doesn't matter which curve you take, whether the total cost or the total variable cost, the steepness or the slope of those two functions for a particular point is going to be equal, okay? Or it's going to be identical. Now, if you're thinking about the marginal cost function, okay, then we said that this represents the steepness of the cost function. For this purpose, I'm going to talk about the total cost function. Then you're thinking about the marginal cost as the steepness of the total cost function. You can see that here the total cost function is very flat, whereas here, as well as here, the total cost function is very steep. So what this means is that for this particular point here, let's assume the point is here, that at that point, the steepness or the slope of the total cost function is minimized or is smallest. Now, since the marginal cost is the steepness or the slope of the total cost function, that also means that at this point, the marginal cost is minimized. So this is going to look like this. Okay? So here, this is the marginal cost. Okay? Now you can see that since here it is very steep, this corresponds to a higher marginal cost function. Okay? Now, let me look at the total cost function. Okay? And what I'm going to do is I'm going to derive the average total cost next. Remember that the average total cost is the total cost divided by the quantity. And here it would come in handy if you remembered what we have seen in the production theory or the producer theory video. Okay? What this means is that if you are taking a particular point, let's take this point here, and you are connecting this point to the origin, then you are having, for this point, you are having the quantity here, and you also have the total cost here. So you have rise over run, total cost divided by Q, and hence the slope of this connecting line represents the average total cost. Okay? Now, if you are comparing the steepness of the connecting line, the red line, which represents the average total cost, to the slope of the total cost function itself, which represents the marginal cost, then you see that the average total cost at this point is higher than the marginal cost. So what this means is that for this particular point, the average total cost is above the marginal cost. Let's assume it is here. Okay. Now note that there will be a point, and this is very similar to what we have seen in producer theory. We have a point here. Let's assume it's here. And if you are connecting this point to the origin, like this, then again the slope represents the average total cost. But you will see that there is no other point on this total cost function which you can connect to the origin that is going to give you a lower slope, okay, or a smaller slope. So what this means is that at this point here, the average total cost is minimized. Now, but at this point here, we also know that since the average total cost is minimized and it is just touching this point, that it also corresponds to the slope of the total cost function. And keep in mind, the slope of the total cost function is the marginal cost. So what it means is that at this point here, the marginal cost and the average total cost are identical. That is the first observation. The second observation is that the average total cost at this point is also minimized. So here, this means that the average total cost is smallest. So when we are drawing, if we were to calculate the marginal cost, the average total cost for each point, then we would get a function that would look like this. It's inverse U-shaped. So here we have the average total cost. Okay. Now note that if you are comparing this picture to the picture we have seen in producer theory, okay, then this is basically flipped upside down. Okay, so now you have those U-shaped curves. Now note that what I have not drawn in this picture is that we also have what is called the average variable cost. Okay, so here the marginal cost is independent of which function I take, whether it's the total cost or the total variable cost, because both of them are parallel. But it actually, so it doesn't matter for the marginal cost, but it actually matters for the average total cost or the average variable cost. So the average total cost and the average variable cost are not going to be identical. But what you can see, and I'm just going to sketch this here because otherwise the picture is going to get very, very messy. If you are taking this point here, if you want to calculate the average variable cost, you can, again, for this point here, you can connect it to the origin. And you see that the slope is going to be smaller than the connecting line for the average, for the total cost. So what this means is that for any point you're going to choose on the total variable cost function, and you're connecting that point to the origin, that for the same point, the average variable cost is going to be lower than the average total cost. Okay? So what this means is that the average variable cost is going to be below the average total cost. just call this the ABC for average variable cost. Okay, and the minimum of the average variable cost again is where the marginal cost intersects the average variable cost. Let me use this computer-generated graph to illustrate what we have seen so far a little bit clearer. At the top here, we have the total cost function, okay, that tells us, based on our output, how many units of a good we produce, of how much it is going to cost us. Okay, so here we have the total cost function. Below, we have the average cost and the marginal cost. But note that for the average cost, we also differentiate between the average total cost and the average variable cost. Okay? Now, what this graph shows us is, for example, if we are looking at an output of 10, say here, then it tells us that the average cost associated with producing 10 units is about $130. Okay, so each of those 10 units is going to cost us $130 to produce. Now we have here the intersection, so this one here is the average total cost, which we have the $130. Now here we have the marginal cost, and so assume that it is a little bit over $100. Okay, so what this means is that if we were to increase our production from 10 to 11 units, that our cost would increase by approximately $105. Okay, and note that if we are only interested in the average variable cost, okay, now note that for the average variable cost, this does not include the fixed cost. Then we see that it would cost us not $130, but if we take out the fixed cost, then each unit of output would only cost us $90. But of course, we always have to pay the fixed cost. But we will soon see that differentiating between the average total cost and average variable cost is very important. Now note that everything we have seen so far only relied on the production technology and the input prices. Okay? We did not say anything about the output prices, in the sense at what price can we sell our output. Okay? And this is what we are going to do next. But note that for most of what is following, we are going to rely heavily on this graph here. I think that this graph here is one of the central aspects of microeconomics or producer theory. So for what we are going to do next, assume that the total cost function is equal to a fixed cost of $450, and the variable cost part is equal to 100 Q minus 3 times Q squared plus 0.2 Q cubed. Okay, so here you have the fixed cost, and this part here represents the variable cost. Consider this Excel sheet where in the first column here we have Q, which is the output quantity, and this goes from 0 all the way to 25. Now, in the second column, we have the cost. And note that the cost function here represents the function I have given you before, in the sense that it is $450 of fixed cost plus 100 times q minus 3 times q squared plus 0.2 q cubed. So you can see that even if the output is 0, we are still stuck with the fixed cost of $450. And then as you start to increase your output, your total cost is going to increase as well, okay, according to the equation. So let me just call this here to be more specific. Let's just call this total cost. Now note that in the 3 subsequent columns, I have calculated the marginal cost, the average total cost, and the average variable cost. And so what this represents is the marginal cost is the additional increase in cost from producing 1 more unit of output. That is the marginal cost. The average total cost is the total cost divided by the quantity we produce. So for example, take the number of 640 in total cost. Then at 640, we are producing 2 units of output, and hence the average total cost for the output of 2 is 640 divided by 2, which gives us 320. The average is, in this case, is only the variable cost part, in the sense that we have the total cost of 640. $450 are the fixed cost. So in order to calculate the 95, what you would have to do is you have to take the 640. You have to subtract the 450. So that gives you 190 in variable cost, and 190 divided by 2 gives you the 95. Okay? So this is what we have seen so far. Now note that we also have here the various functions associated with the total cost. So this is what we have seen before. We have the average total cost. We have the average variable cost, which is always below the average total cost. And we have the marginal cost. Now note that, and we have seen this before, that the minimum of the average total cost and the minimum of the average variable cost is intersected by the marginal cost function. All we have talked about so far is input prices and the total cost associated with producing. What we are going to do next is we are going to introduce the output price. So at what price are you actually selling the 1, 2, or 3 units of output? Now here, for the moment, we assume that the price, the output price, is constant. So in this case, we are assuming right now, for the moment, we are assuming that the price, the output price, is $160. So what this means is that if you are selling 0 units at $160, of course you do not have any revenue. But if you have, if you're selling 1 unit of output at $160, you have a revenue of $160. For 2 units of output, you have a revenue of $320, and so on. Now, what a firm is interested in is profit maximization. So the profit is equal to the revenue minus the total cost. Okay? So you have a revenue of, say, $160. You have an average total cost, so you have a total cost of $547. And hence your profit is 160 minus 547 is equal to $387, and so on. Now note that everywhere where it is red here means you are making a loss, Okay, so you're making a loss for very small output quantities and very high output quantities, but in the middle you are actually making a profit. Now the function, this column with the profit, I have represented here in this graph, and as you can see, you're making a profit for small output quantities and then it's increasing, and at some point it is maximized here and then it is decreasing. So if you are a firm and given your total cost and given the output price of $160, then you want to maximize, you want to produce around 17 to 18 units in order to maximize your profit. So if you're going back to the sheet, then you see that it is the maximum here is at 16 units, okay? And you see that this is profit maximizing. Now, and here comes the important part. Now, let us have a look back at the functions of marginal cost, average total cost, and average variable cost. And note that here we have a price of $160, and we said that the profit maximizing quantity is around 16 to 17 units, okay, so which is right here. Now note what happens at that output. The price is equal to the marginal cost, okay? So if the price is equal to the marginal cost, then this is where we are going to produce. So what is the intuition behind this? Think about what the marginal cost represents. The marginal cost represents the increase in cost from producing one more unit, okay? And also in this case, think about what the price represents in the sense that it is the additional revenue you are getting from producing or selling one more unit. Now consider the prices here. Suppose that the price is, again, it's $160. So if you are producing one more unit of output, then you are going to receive $160. Now suppose that your marginal cost is $150 from selling that additional, from producing and selling that additional output. So if you are producing this output and selling it, you are getting the price of $160, but the additional increase in cost is only $150. So what this means is that if you're producing this additional unit, you're making a profit of $10, or your profit is going to increase by $10. Now suppose that the marginal cost from producing and selling an additional unit is $170. Then in that case, you are receiving $160, but it costs you an additional $170 to actually produce that unit. And hence, you're not going to do this. So if the marginal cost is smaller than the price you receive, note that in this case, the price is going to be the marginal revenue. Then, so if the marginal revenue is bigger than the marginal cost, you're going to produce and sell that additional unit. And if the marginal revenue is smaller than the marginal cost, then you're not going to sell that unit. So at the optimum, or at the profit maximizing, in the profit maximizing situation, you have actually the marginal revenue, or the additional revenue that you're getting. In this case, it is the price of $160 is equal to the marginal cost. Now, let us continue to play around with this Excel sheet. Right now, we are in the situation where we have a price of $160, and we know that in order to maximize profit, we have to set the price equal to the marginal cost, which gives us the output quantity of around 16 units. Now, what happens if the price is actually decreasing? Suppose it is now, say, $110. Okay. Then what we can see is that there's not a single quantity that we can produce that gives us a profit. Okay. Profit in the sense where our revenue is bigger than the total cost. Now, when we look at the profit function though, okay, then we see that it is negative for any output range. However, we see that despite the fact that it is negative across the entire output range, that if we start producing units, or if we start producing output, that we are actually minimizing our loss. And in this case, the loss is minimized at around 12 to 13 units. Now, we can confirm this in the Excel sheet, where we have the minimized loss at around, in this case, at around 11 units. Note that the numbers are not matching up perfectly because here those numbers are actually rounded and only for integer values of the output. So in this case, what it means is that despite the fact that we are making a loss, we need to continue to produce in order to minimize our loss. Now the question is, how is that possible? Or why is that the case? Now let us have a look at the marginal cost, average total cost, and average variable cost function. Note that in the case of the price being at $110, we said that our profit maximizing output is around 11 or 12 units. Then you can see that the marginal cost intersects the price at around those 11 to 12 units. But also note that now we have the average total cost being above the price at that range. Okay. So what this means is that, and this is indicative of the loss, that on average, it costs us more to produce those units than the price we are receiving. This is why we are making a loss. However, note that the price at that output level is still above the average variable cost. Now, what this means is that our average variable cost, or the average cost, if you're just considering the variable costs, are still covered. And we are actually making a little bit, if you will, we are making a little bit of a surplus if we are considering this price of $110. That little additional surplus is actually going to cover parts of the fixed cost. Remember that the fixed costs are costs that we cannot avoid even if our output is zero. So if the price is above the average variable cost, then we are covering, we are covering the materials associated with producing the product. And not only are we fully covering the materials associated with the product, but we also have leftover money that can cover the fixed cost. Now, suppose that the cost goes to 80. Now, in that case, you can see that the profit function is always is negative, and in addition, the cost minimizing point, or the loss minimizing point, is when we are actually producing 0 units. So, in the sense that if the price is below the average variable cost, we need to stop producing. Now, the question is, how does this relate to deriving the actual supply function? We have seen that at the price of $160, the firm is setting the price equal to the marginal cost. And we have also seen that at any other price below that, the firm is actually setting the price equal to the marginal cost. So even if we are doing this for 150, then the profit maximizing output is around 15 units. And you can see that that it is around 15 units where we are maximizing our profit. So what this means is that the portion of the marginal cost that is above the average variable cost is representing the supply function of the firm. Okay. Now this finding is extremely important. The marginal cost function, or certain parts of the marginal cost function, represent the supply function of the firm. When I say certain parts, that means the part which is above the minimum of the average variable cost. Okay? Because if the price is below the average variable cost, we are making a loss and we are shutting down. Okay? So this is an extremely important finding. So in this graph here, I have simply represented the marginal cost, the average total cost, and the average variable cost. And I would like to reiterate of how we derive the supply function of the firm. Now note that in this case, we said, this is what we have seen in the Excel file. If we have, say, a price of P1, then what the firm is doing, the firm is setting the price equal to the marginal cost, and that determines the output quantity. Let's call the output quantity here Q1. Okay? So if the price is P1, then the output quantity is Q1. Okay? Now, we said that in this case, the firm is making a profit. And we will get soon into this, but you can see this, that for the output quantity of Q1, the price is here at P1, but the average total cost is below. It's right here. So this difference here, this distance, we will soon see is the per unit profit the firm makes. Now, if the price goes down to, say, P2, then again, the firm sets the price P2 equal to the marginal cost, and the output quantity is going to be Q2. Okay, and again, we see that we have a positive per unit profit, which is equal to the vertical distance here. Now, let us have a look where the price is such that it is exactly at the minimum of the average total cost. Let's call this P3, and let's call this Q3. And then you see that at this point, the price covers exactly the average cost to produce a quantity Q3, or per unit of output. Okay, so here the firm does not make a profit anymore. So everything above the minimum of the average total cost, the firm is making a profit. Okay, and so let me use the green color. So the supply curve of the firm is represented by this green line here. Okay. Now note that if the price drops below the minimum of the average total cost, say to P4, but is still above the average variable cost, so here we have Q4, then it turns out that the firm is making a loss, because now the average total cost is above, or the per unit cost is above the price, so the firm is making a loss, but it covers the average variable cost, or it covers the variable costs associated with production. And the surplus here, this goes to the to cover the fixed costs. Okay, and hence in this case here, even if the firm is making a loss, as long as the price is above the average variable cost, the firm is still continuing to produce, and hence this is part of the supply function as well. Now, if the price drops below the minimum of the average variable cost, then the firm is shutting down, okay? Or the firm stops producing. So it turns out that this part here of the marginal cost function is irrelevant. And the supply function is only represented by the part of the marginal cost function, which is above the average variable cost, okay? So this is an extremely important finding, that the marginal cost function is equivalent to the supply function of the firm. So if you want to summarize this, okay, so we have if the price is above the average total cost, then the firm is making a profit. If the price is below the average total cost, but above the average variable cost, then the firm is making a loss, but there is no shutdown. Okay, so the firm continues to produce. And if the price is below the average variable cost, the firm shuts down. Okay, so we have a shutdown. Okay. So this is summarizing how the supply curve of a firm is derived. Okay? So note that in consumer theory we have seen on how to derive the demand function for a good. Now here we have the supply function for a good. Let us have a look at an applied example to illustrate the concept of supply curve and how it coincides with the marginal cost. Now here I have a graph which is published from the Bank of Canada in their monetary policy report from January 2015. Okay? And so what it shows the cost of oil production depending on the quantity of oil production, the output, and on the vertical axis we have the dollars per barrel. Okay? So now note that for very low production of oil, it is actually Saudi Arabia who can produce the oil at the minimum marginal cost. Okay, so if you're thinking about this, oil production in Saudi Arabia or even in other OPEC countries is very simple because you only have to drill into the ground and you get the oil. Okay? But if your oil production is going to increase, then you are going to move from sources that are relatively cheap to sources that are getting more and more expensive. Okay? Because intuitively what you would do is, if you want to produce something like oil, then you would go with the cheap sources first, and as you produce more, then you would only subsequently go to more expensive sources. And this is what is illustrated in this graph here, okay, where you are going from the cheap sources to the relatively more expensive sources. So if you are, for example, looking at Canadian oil sands, which is basically digging up sands and squeezing out the oil, which is very expensive to do, then you see that you are only going to this type of source if the price is very high, or if you have to produce a lot of oil. Okay, otherwise you're not going to do this. So here I have slightly simplified the oil price, or the marginal cost and the supply of the oil price. And let us have a quick look of what some of the implications are. And this is already jumping ahead a little bit to the section on supply and demand. But suppose that, say 30 years ago, you had a demand function that looked like this. Okay, in the sense that you had a prevailing quantity, let's call it Q1, and you had P1, okay, where P1 represents the oil price. But now, if you have developing nations that are demanding more and more oil, think about China in this case, then the demand function is actually shifting to the right. And hence, you are not going to be at the original equilibrium point more, but you now have the demand, let's call this demand 2, okay? And here we have demand 1. So now you are having a higher production quantity, and you're also having a higher oil price, okay? Now note that, and this is what we have seen in the previous graph, that here you're using very cheap sources, but as the demand increases, because you also have now a price increase, then even more expensive sources like Canadian oil sand are actually getting profitable, okay? And hence, oil firms have invested in capacity to actually achieve those more, to get those more expensive sources. You have seen something very similar in the 70s, late 70s and early 80s, when OPEC actually increased the oil price. Before that time period, it was not profitable to, for example, drill for oil offshore. Think about what the UK or the Netherlands or Norway have done in the North Sea, or think about the Gulf of Mexico. But now you suddenly have this increase in the price of oil, and then suddenly those more expensive sources are actually getting profitable. Now also note that what is very expensive with those sources are investing in actually the actual capacity. So once you have invested, for example, in an oil platform, to actually extract the additional oil is not that expensive anymore. Okay, so this would be one way of thinking about the supply and the demand of oil, based on the fact that the supply function represents the marginal cost. Now let us do a second example where we are actually looking at the ride-sharing app Uber, or the company Uber. Now think about the supply function of drivers, okay? And you have the number of drivers, or the output, on the horizontal axis, and you have the cost per mile on the vertical axis, okay? Now what you would expect is that if the price, or what you would expect that if the price is low, so think about, for example, you have a demand, say on a regular day that looks like this, then you would expect a certain quantity of drivers being out there, and you would expect the regular price, if you will. Okay, let's call this P1 and Q1. Okay. Now, what you would expect in those in this type of scenario is that you would have the drivers that are out there would be with, say, fuel efficient cars, okay? Or hybrid cars, right? Because they have the lowest cost to provide or to supply drives or rides. Now, if the demand suddenly surges, okay, so for example, so here you have the demand 1, let's call it now demand 2. Think about some event happening in downtown. Then you suddenly have a lot of people demanding a driver, an Uber driver. Okay. Then in this case, in order to actually incentivize people with less fuel efficient cars to provide rides, the price has to actually increase. So if the price gets higher, then even if you are driving a less fuel efficient car, you are going to provide the service. Okay, less fuel efficient cars. Okay. Now note that a couple of years ago, I actually had on a normal evening, I actually rode with an Uber driver, and he actually had a lifted truck, and the cost or the price was not very high. So theoretically, you would not expect this type of car if the price is very low, because the car is not very fuel efficient. Okay, so what holds in theory does not always hold in practice. I would like to reiterate how to determine the profit and the loss from the graphs which depict the marginal cost, average total cost, and average variable cost. So here we have a price that is a little bit over 150. Okay, so here we have the price, and the function here is the marginal cost, and this function here, or this curve here, is the average total cost. Okay, now the firm sets the price equal to the marginal cost and is going to produce at this level of output here. Okay, now in this situation, what the firm receives is the price, but on average the cost associated with producing 1 unit of output is this. So the difference here is the per unit profit on average, the average per unit profit from selling its output. Now, since we have here the per unit, and we have on the horizontal axis, we have the output, then this rectangle here which would be the per unit profit times the number of units. This rectangle here represents the profit of the firm. Okay, so in this case, say the price is at, say, 160. The cost is, say, at 130. So the per unit profit is $30. The firm is selling, say, 16 units. Then the profit is equal to 30 times 16, which is represented by this area here. Okay. Now let us have a look what happens if the price is actually below the average total cost. Now in this case here, okay, note that this is a situation where the firm is still producing. So the firm is setting the price equal to the marginal cost. Okay, note the firm is still producing because the price is above the average variable cost. So here the firm is producing, say, 11 units, but the price it receives is, say, $110, whereas the per unit cost is, say, the per unit cost here is, say, $125. So the firm is making a per unit loss of $15. Now, because the firm is producing 11 units and it makes a per unit loss of $15, then this area here represents a loss. Specifically, the loss in this case would be the 11 units produced, or the per unit loss of $15 times 11. Okay. Note that this type of analysis is going to come back when we are going to talk about the perfect competition.